Hello everyone, this is a video lecture for Calculus 1, section 3.7, rates of change, which just basically means derivatives. And I have nothing new to say. First problem, v equals 4500 times 1 minus 1 over 50 times t all squared. And they say that we're going from 0 to 50, and that's something, I guess. Find the rate at specified times. Well, what they mean is derivative. So part A is find v prime at 5. Well, what we're going to need to find first is v prime. So the 2 is going to come down to the front, so we actually get a 9,000. 1 minus 1 over 50t to now to the 1 power. This was a complicated inside, so the derivative here would be negative 1 over 50. 9,000 divided by 50 is 180, I think. I'm just kind of looking at my notes. Notice it could be a negative. 180, 1 minus 1 over 50t. Cool. And so now I can finally plug in my 5. So negative 180. 1 minus 1 over 50 times 5, and it ends up being a negative 162. And that's all we have to do. You just repeat this a couple times because they're asking for multiple things. At the bottom, they're saying, hey, where's the minimum and where's the maximum values for this rate of whatever? And it's actually very simple because if you look back here, they gave you the limits. And so 0 is going to be your... Actually, hold on. It's 0 for your max and 50 for your minimum. That's just how it works out because, well, you plug those in and you'll see that this one's a smaller one, that's a bigger one. So there you go. The end. The end. Next question. 37005. And so there's this graph, V of t, and it has this, it looks like a sine wave. It kind of comes up and comes down. And then it comes back down like this. And this is at 1. This is at 2. It ends at 3. Awesome. And because it's velocity, this is my derivative. And so let's talk about this for a second. My velocity is getting higher, higher, higher. And then at this point here, my velocity is at its maximum. And so then it goes down here. And notice this is velocity is 0, but that means my position has changed greatly. So I have a little car, and it's going faster, faster, and then it starts to slow down. And then its velocity is 0, and it stops. Okay? Then it goes in reverse. This is reverse. I don't know how far. It might go back to where it was right there. I don't know. But... at the moment here at the end of this graph, it's actually going in reverse really fast, but we just stopped the movie. So when is it speeding up? That's a really good question. And then when is it slowing down? Again, a very good question. What do they mean by speeding up and slowing down? Well, I'll tell you what they mean when I give you the answers. So here's the answers. It's 0 to 1. And then 2 to 3. This guy here is 1 to 2. So what do they mean by speeding up? Well, there's a difference between velocity and speed. I don't know if anyone ever told you this, but I'll do it right now. So velocity is not the same as speed. They're closely related. A lot of times we think of them as the same because of how our human minds are working here. But velocity means... I guess you could say it's like direction. It's speed plus direction. Speed and direction. While speed is just speed. Like speed on the speedometer. So then, you're going from 0 and you're cranking it up and you're going super fast. Here's 80 miles an hour or something like that. That's speed. Now, I don't know how your car works, but if you're going in reverse, does the speedometer still work? Let's just do a digital one. That way I know it's going to work. If you got a digital speedometer, and you go in reverse, then it should like read out, hey, you're going 10 miles an hour in reverse, which I think is kind of fast actually. But regardless, there is a speed. It's just that you're going backwards, and so when you're speeding up, is that you're going faster in any particular direction. They didn't specify velocities here. Here you're slowing down, and that's pretty obvious. You're just putting on the brakes. When are you doing the accelerator, and when are you putting on the brakes? That's actually all they're asking about, okay? So we're speeding up, we're slowing down. Here we stopped. We applied the brakes all the way to a stopping, and then we put on the accelerator again. But again, this is kind of like in reverse. So when you're going reverse in your car, you're actually pressing on the accelerator, therefore you're speeding up, technically. Oh, that was a lot of talking. So 37009. I got H, which I think is a height, is 3 plus 21.5 T minus 4.9 T squared. And they want to talk about velocities and maximum minimums and stuff like that. Okay, so this right here, this little part is gravity. Normally we think of gravity as negative 9.8 meters per second squared. We'll divide it by 2, and it's going to be the 4.9. And the reason why is because your formula here has a 1/2 gt squared, something like that. This right here is your initial velocity. Initial velocity. I didn't spell velocity. I'll just put vel. Initial velocity, and so you're starting going up or positively, and gravity brings you down, and then this is your position, your initial position. Okay, so in my mind, we're starting here at 3 height, and then it goes up in the air, and then it comes back down eventually, and it would hit the ground. All right, so they're wanting a couple things. I'm going to go ahead and give you the velocity is going to be just h prime, which would be very simply here 21.5 minus the 2 comes down again to make the 9.8 t, which is what we're familiar with gravity. Okay, so now that we have those, part A says find v of 2. And so guess what you're going to do? You're going to plug in a 2 here. And blah, 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 calculator 1.9. There you go. Okay. Part B says, when is h at a max? All right, so how does this work? Well, to find a maximum, we're going to be taking the derivative equals 0. Sorry, let me do this. The derivative equals 0. That means my velocity equals 0. That means I'm going to take this formula right here and set it equal to 0. And so then I move this over, and I could divide by the 9.8 to the other side, and da-da-da, I got 2.19 seconds. Okay, cool. And then it says, well, what's the height? What's the max height? Now that we have when the max happened, it's very easy to find the max height because I'm going to take my height formula and plug it in. So 3 plus 21.5 times the 2.19. Again, I'm just plugging this guy in. And then minus the 4.9, 2.19, and then all squared, blah, 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 26.58. And then apparently that's in meters. And apparently there's even more questions about stuff, but I didn't feel the need to actually put anything on my paper, so it means it's probably good enough. Next problem, I got a of x is equal to x squared. A prime of x is equal to 2x. So what's a prime at 16 is 2 times 16 is 32. This is the square wafers problem, I think. I don't remember this problem. I haven't seen this problem in years, probably. At least a year. I have no clue what this all's about. But I'm glad we're talking about it. So the square wafers problem, 013, all you do is find the derivative and plug in a 16. Obviously, I don't know what's going on, and that's okay. I don't mind not knowing, okay? I'm okay with just saying, this is how you're supposed to do the problem. This is the meat and taters of it, okay? This is not actually the holistic, what should we be doing on this problem? Just do that and you're good enough and it's okay. All right, next problem. It says find the average rate of change of the area of a circle. Oh my, here we go. Of the area of a circle, and it says my radius starts at 4. Huh? So I have a circle, and I'm guessing it's going to ripple out. So what is the rate of change for the area as my radius increases? So my area formula for a circle is pi r squared. We're going to need to find our derivative. So then, of course, 2 pi r, if you're taking it in terms of r. Doesn't that look familiar? So what I'm going to do is I'm going to find this average rate of change. To do an average, what I'm going to do is I'm going to add them up and divide by 2. Okay, so it's like a plus b divided by 2, that kind of thing. And then rate of change means derivative. That means a prime. So I used the incorrect things here. I should probably said x plus y divided by 2. There you go. That's better. X plus y divided by 2. Rate of change is a prime. And so I'm just going to do that. So part A, it says from 4 to 5. And so what they're trying to say is a prime of 4 plus a prime at 5, and then divided by 2. So I'm just finding the average. And so I'm plugging that in. I got 2 pi times 4, 2 pi times the 5, all divided by 2. So we got 8 pi plus 10 pi all over 2 is equal to 9 pi. There we go. And so then the next one is something about like at 4, instantaneous rate of change at 4, something kind of like that. So then you plug it into 4 and you get 8 pi. These problems are not hard. They're not hard. It's just trying to explain what you should be doing on them, mathy wise. All the words, all the clutter. Just get rid of all that, and this is what you're supposed to be doing. All right, next problem. I got PV is equal to nRT, and there is definitely a purpose to this formula. Pressure, volume, rate, something or other. I don't know. Something about pressure and volume. And so they give you a lot of values. My R is 0.0821. My P is equal to 8.0. My V is equal to 12. My N is equal to 10. My P prime is equal to positive 0.13. I'll talk about that here in a second. And then V prime is equal to a negative 0.16. Now, I have gotten this problem wrong very often, and I know why. I put a little indicator here to tell you, positive and negative. They're going to say increases and decreases. So what they're trying to say here, increases, decreases, positive and negative for my derivative, okay? Ultimately, what they're wanting is dd dt or dt dt. I know that's kind of weird to have it like t's and t's, but all of these are in terms of t unless they're a constant. Let's just figure this thing out. Okay. Actually, this is the last question, so here we go. So PV is equal to nRT. So find the derivative implicitly, I guess. And so what we actually have is P prime V plus PV prime. N is definitely a constant, so I don't worry about that guy. R is apparently a constant, so I don't worry about that guy. But T is not, so T prime. To get T prime by itself, I divide over here. So T prime is what my goal is. P prime V plus PV prime over NR. And so then, that does not look very good. And so then I just basically plug everything else in. So a positive 0.13. My V itself is a 12. My P itself is an 8. My V prime is a negative 0.16. Then all divided by N, which is a 10. And then R, which is a 0.0821. Calculator, and you get 0.34104. There you go. And that's all I got. That's all I got for this section. Thank you very much, and have a great day.